right, so in this problem we're going to be doing the hoop pendulum. Before I get started with that though, I want to remind you a little bit about regular pendula. So you'll normally think about that as a mass on a string. So if I hang a mass from the string, the mass will swing back and forth, oscillate at a frequency you can determine based on the length of the string and gravity. A hoop pendulum is a little bit more complicated. There is no string. Rather, it's just a mass that is pivoting about this contact with this post. Before we get into that exactly, what I'll do is I'll talk about one other thing, which is something that's like the simple pendulum. This is now, rather than a mass on a string, it's a rod that has mass. And you could imagine if I let it go, it'll swing back and forth about the pivot at the top. The motion you can think of as having two parts. One is the center of mass motion, so you can focus on a point mass at the center of the rod, which will oscillate back and forth. And then in addition, around the center of mass, there is a rotation back and forth. So there's both translational motion of the center of mass and rotation about the center of mass. So in the hoop pendulum, you're going to solve this problem taking into account the rotational inertia of the hoop. And what hopefully you'll be able to do when you're done is determine the frequency of the oscillation. The only thing you're going to need to know is the radius of the hoop, which we can measure right here to be about 141 millimeters, as you can see. So I'll get it swinging, and from the timer on the screen, you'll be able to measure its period.